with one-dimensional movement is movement of a point in a number line, okay, or just in a line, all right? And so we got a point that's moving along a line. We've got a couple important measurements. We got displacement, which is just the change in position. So if this point is at point B, it's over here, and at time A, it's over here. The displacement is x of b minus x of a, all right? So x is its position at some particular time. Then velocity is the derivative of position. Change in position is velocity. If the velocity is positive, the thing is moving right. If the velocity is negative, then it's moving left, okay? So velocity, go left and right, that's its sign. And then the change in velocity is acceleration. So the derivative of velocity is acceleration. And if acceleration is positive, it's moving right. If it's, it's accelerating right. If acceleration is negative, it's accelerating left, okay? And then, so velocity has direction, but if we take the absolute value of velocity, we just get the speed. If we just want to know how fast a car is going, it's going 20 miles per hour. That's a speed. We don't care if it's going to the left, to the right, north, or south. Speed is just an absolute value. And then we've got one relationship here with velocity and acceleration. If the velocity and acceleration are going the same direction, meaning they got the same signs, then it's going to be increasing because the acceleration is pulling it one way. If the velocity and acceleration have different signs, then its speed is decreasing because it's like doing a tug of war. So the key connection is that the derivative of position, and in this case I got position as x, derivative of x of t is v of t, velocity. And then the derivative of velocity is acceleration. Okay. And if we put those two things together, the second derivative of position, because we take the derivative once, we get velocity, take the derivative again, we get acceleration. So the second derivative of position is acceleration. So here's a quick example. If we have a function for the position, okay? If we want to find the average velocity, that's the average rate of change here. So we've got to find the position. If we're going for the first 3 seconds, okay? So the position at 3 seconds minus the position at 0 seconds, all over 3 minus 0. All right, and if we plug in 3 here, we got 1/3 times 3 to the third minus 3 times 3 squared plus 8 times 3. This is going to be 9, this is going to be 27, and this is going to be 24. So it looks like that's 33 minus 27, I think. 33 minus 27 is 6. I think I got that. So this is 6 over 3, which is 2. So that's the average velocity. 2, we're measuring in meters, so meters per second. Okay? So that's its average velocity. If we want instantaneous, like we talked about above there, we've got to find the derivative. Velocity is the derivative of position, which is going to be t squared minus 6t minus 8. Just using our power rule there. And then we want to find the velocity at 3 seconds, so that's 3 squared minus 6 times 3 minus 8. Okay. So 9 minus 18 minus... No, that's a plus 8, actually, right? Yeah. All right. So I think that's 17 minus 18, which is negative 1. So the instantaneous velocity at 3 seconds is negative 1. And remember that negative 1, and we should put some units on that, negative 1 meters per second. That means it's moving left. even though overall, on average, it moved right. Okay? So it moved right 2, even though at the moment, at 3 seconds, it's moving left. So speed is the absolute value of velocity. So if we want the speed at 1 second, we're going to find the absolute value of that. So velocity, just using this function up above, we've got 1 squared minus 6 times 1 plus 8, which is 1 minus 6, which is negative 5 plus 8. I think that's 3. Okay, meters per second. Okay. So that's the speed. It doesn't tell us left and right. It's actually going, well, actually it is going right, it looks like, so at 1 second. All right, then this one's probably the trickiest one here. Total distance, and this is the main thing I wanted to point out in this video that I'm actually making here. So total distance in 3 seconds, we've got to figure out where is it stopped, or when did it stop. Okay, when did the point stop? And so that's found when we take the velocity equals to 0. So the velocity is t squared minus 6t plus 8, and we set that equal to 0. So we can factor t minus 2, t minus 4 equals 0. So at t equals 2 and t equals 4 seconds, the point stopped. All right. So what we want to do is we want to figure out the total trip. Now, you don't have to do this, but I'm going to do a quick number line here. 0, 2, 4. And if we plug in to this function, if we plug in something like 1 minus 6 times 1 plus 8, that's positive. If you plug in something like 3, we're going to get a negative here. And then you plug in 5 for velocity. This is velocity. You get positive. So what that means is for the beginning of this trip, it's moving right, then it's moving left, then it's moving right again. So it's kind of bouncing back and forth. So we want to know how far it went for the first 3 seconds. In order to do that, we've got to break it up from 0 to 2 seconds, figure out how far that went, and then from 2 seconds to 4 seconds. Okay, oh, no, 3 seconds, sorry. To figure out its total distance, because it was moving right for the first 2 seconds, and then it's moving left. So in order to do that, we need to find the absolute value here of the position x of 2 minus x of 0, and add that to the absolute value of x of 3 minus x of 2. Because this is how far it went in the first 2 seconds. This is how far it went in the 3rd second. All right. And so, well, we know, what did we find up here? We found x of 3 was 6. We need to find x of 2. Well, what is x of 2? That's 1/3 times 2 cubed minus 3 times 2 squared minus 8 times 2. That's looking a little ugly. That's 8/3 minus 12 minus 16, I think. That's not very pretty. So minus 28. So we've got 8/3 plus 4. 4 is 12/3. How about 20/3? It's about 7, yeah? All right. So we've got 20 thirds minus 0, because x of 0 was 0, plus x to the 3, x of 3 was 2, what was it, 6? Yeah, it was 6. So 6 minus 20 thirds. Okay. So 20 thirds is a little bit bigger than 6 here. Okay. So 6 is, how about we do 18 thirds? So this is going to be negative 2 thirds. And we got 20 thirds. And so it's going to be 18 thirds, which is actually just 6. All right.
Isn't it the absolute value? So it would be reasonable.
Oh, yeah. Thank you. Yeah, that was the whole point of it, huh? Very good. Absolute value of that makes it positive. Yeah. That was the whole point there. Come on, eraser. There we are. Good. So 22 thirds is our final answer. Yeah. See, and that's why we got to find out where it turns around, because we add those. That's the total distance rather than having them subtract. So, all right. Well, there you have it. That's kind of the main questions there. Now, one more little thing here that I need to point out. There's a typo up here that I should have caught earlier. But displacement is a change in position. So we're going to subtract x of b minus x of a. But that position might not be, that might not be positive. We need to make it positive. Displacement needs to be positive, so we need to have absolute value there. So watch out for that. All right, hope that helps.